So good morning to all. So today we are going to discuss about how the organization of your OpenGL function is going to happen. So what are the parameters and what are the functionalities of your program when you are writing the OpenGL program? As we have already seen that, so the first line which you have to have when you are writing your OpenGL program is initialization. So in this particular init program, so we have to place all initializations and related one-time parameters settings in function unit. Okay, so you're going to have the function unit, so that is called as GL begin. So inside that particular GL begin, we have to initialize what type of functionality you have to do. So whether you are going to do the point function, whether you are going to do draw the line function, or whatever the function you want to perform. So that particular operation has to be initialized inside the unit. So the next comes server line segment. So it's a one geometric description of the picture that we want to display in the function line segment. So which is a function that will be referred by regular function display function. Okay. So whenever you are going to have the main functions, so the main functions mainly contains a number of regular functions for setting up the display window and getting our line segment onto the screen. So the last one will be GL flush. Flush is nothing but what? So it is going to clear all the keyboard buffer. So normally when you are talking about your C program, so if you are familiar with your C program, then you have encountered, if you are done the programming in a lengthier way, so then you are encounter that particular program. Sometimes your scanner will not accept the characters. So due to what? So due to the filling of the buffer. So when you are going to have the contents which is there in the buffer, so that time the keyboard, what you are going to press, that it is not going to take the input. So during that particular time, I want to clear all the data which is there inside the buffer of the keyboard. So for that one, they are going to make use of F flush in your normal C program or C++ program. So similarly, you are going to your GL program, OpenGL program is going to make use of the GL flush. So the GL flush is nothing but it's simply a one function or API, what we are going to call. So what it is going to do, it is going to uh, it is going to store the data which is which the functionality which you have been performing, and that particular implementation depends upon the implementation of the OpenGL. So because when you are going with OpenGL, so different function is going to perform different functionality, or different API is going to perform different functionality. So during that particular time, so you're going to make use of particular implementations, and you are going to make use of the flush. So basically it is going to clear the buffer. So this GL flush is going to be used. Okay. So the next is we are going to discuss what are the different header files which is going to be used in your OpenGL program. So normally when you are going to have it, let us we start with the header files. What are the different header files you are going to make use of? So we are going to have to draw the window, right? So if you want to draw the window, you should create the frame and all. So for these things, the APIs which will be included here is in window. So the APIs which will be included, APIs will be written in window. So now normally if you are going to GL functionality, so like you are going to have GL begin is there. So these things, these APIs are written inside the GL.h. So if you take GLUT, so that is graphical library utility. So this is going to be used in GLU.h. So those functionalities, some of the functionalities which are not supported by GL.h, so it will be supported by GLU.h. So those APIs will be written inside this particular GLU.h. So the last one is your include glut.h. So if you include glut.h, by default, it is going to include the things, because all the functionalities which is defined by gl.h and gl2.h. So those functionalities which are there in gl.h and gl2.h, so that will be written in glut.h. That is all in APIs or inbuilt function which you are going to have. APIs and input function, inbuilt functions, inbuilt function supported by GL and GLU. So both supported by GLU and GLU. So that will be defined inside your glut.h. That is defined inside your glut.h. So if you use glut to handle the window managing operation, so what at the time we are going to perform? So by default, we need not have to include GL and GLU.h, because already these functionalities will be handled by the glut.h. So it's already included in glut.h. So we need not have to include gl.h and glu.h. That you come to know when you are writing your program in OpenGL. So now, so once you have the header file, so there are different functions which the OpenGL is going to perform. So what are the different functions you are going to have according to your syllabus point of view? Because there are a number of syllabus you are going to have. So like we are going to have the 2D transformation of any object. We are going to have like any 3D transformation you are going to have. So here in this particular module, first module, so we are going to discuss about what are the geometric primitives you are going to have. So in the geometric primitives, according to your syllabus, so it is going to include what? So it's going to include the points and line segments and polygon and etc. So like it may be including the triangle also, or it may be including the rectangle. Okay. So there are different operations what you can perform on these particular geometric shapes, like enhancing the uh, image. So like a scaling, or it may be a rotation, or it may be a transformation. So now, whenever you are going to have these particular primitives, so these are the geometric primitives. That what which are the geometric primitives is going to be a points, line segments, and polygon, or it may be etc. So etc. may be either it may be triangle or rectangle. So now, if you are going with this particular geometric pipeline, so this particular geometric pipeline, as we have already know that, so it is going to have only one two ends, one to enter, other to exit. So you are going to have the geometric pipeline, one to enter, other to exit. So this primitive will be passing through this particular geometric pipeline. Now, when you are passing this particular geometric pipeline, so we are going to decide that whether that particular primitive is going to be visible or not. So now, if it is not visible, how I have to make that one as visible? How the primitive should be visible on the screen? So that I have to be doing that one. So these are the some of the operations your OpenGL has to perform. Now, so it is going to perform different operations. So that geometric transformation, if you take, so they are set as you have to whenever you are going to have any object to be placed, and I have to do the rotation for that particular object. So I can do that particular operation. So I can do the scaling, and you can do the mirroring. So mirroring you can do it. So then etc. So mirroring, and it can be applied on the primitives which are displayed on the screen. So primitives are nothing but what? So the primitives are nothing but your line, points, polygon. Polygon is nothing but a number of sides it is going to have. So if it is going to have 3 sides, it is a triangle. If it is about 4 sides, it is a rectangle. So if it is a 5 sides, it will be a pentagon. So like that. So you are going to have different polygons. So for this particular thing, who has to write the program? So you are going to write it by the programmer. So this programmer can create what? So programmer can create the geometric primitives. So if you go to the general syntax of your OpenGL program, so always it is going to begin with GL begin. So GL begin indicates that what type of object or primitive you want to build. Okay, so it is going to be beginning of the object. So if any object or primitive, beginning of the object or primitive, beginning of the primitive. So now, if you're going with the GL of end, it is going to specify that it is going to be end of the primitive. Now, if you go with the screen, so the screen will be having some dimension, right? So you're going to have the dimension here. So when you're going to have the dimension, so dimensions will be there. So how many, because all these dimensions will be represented with respect to the pixels. So already you know that one. So if you go with the GL begin, so as I already specified, so it is going to specify you the type of the object, and its value can all be as follows. So first, what I need to pass inside your GL begin. So GL begin, I'm going to pass the GL points. So your GL points is nothing but what? Can anyone tell? It is nothing but the symbolic constant. This symbolic constant is predefined. The symbolic constant which you are going to have, it is predefined. So you're going to pass this particular GL underscore points as a parameter. So now when you're specifying that one inside your GL begin, so if you're specifying that one as GL begin of GL underscore points, so what it is going to specify? So whatever the vertex you're going to specify in your program, so that particular vertex will be viewed as a point. Okay, so the side, and whenever you are going to have the vertex, it's going to be displayed as a point. So if you are using this particular symbolic constant, so already we know that all the symbolic constants are predefined. Okay, so since they are already predefined, so you cannot change that one when the program starts. So even if you're going to take the point, so point is there, right? So this small point, This is bigger point. So this will be having that bigger point. So what I am varying, I am varying the size. Okay, I am varying the size. So the size of the point would be of at least 1 pixel. If we take the points, so the point, whatever I'm going to represent, that should be of at least 1 pixel. So what do you mean by pixel? It is nothing but number of rows and columns inside a given screen. So for example, if we take, it will be in which form? So whatever the pixel you are going to have, it will be in matrix form. So it is in rows into column form. Okay, so that is what it is going to refer to. So if we are going with the pixel, so always this will be the same way. It is going to be in the square block of your screen. Okay, so this individual point square is called as pixel here. So if you're going with, for example, 1260 by 960, so that is nothing but what? So the number of columns which you are going to have is the matrix is of the size what? 1260 into 960. So the number of rows which you are going to have is 1260, and the number of columns which you are going to have is 960. So that's what it's going to specify here. So now when you are going to have this particular pixels, so each pixel where you are going to have, okay, so it should be having 1 pixel, the point which you are going to define. So it should be of at least 1 pixel. So if you want to have the bigger points, then I have to place in different blocks, different pixel. I have to place the points. Okay, so then only it will become bigger. So then the size will be increased. Now, if we take the coordinate question, so first when you want to specify that one in point. So for example, at the top left, so it will be what the pixel array of that particular pixel will be 0, 0. So if you take this one as row 0, okay, it will row 0. So if you take this one as column 960, so if you take 0, 480, for example, so that means what? So the point is going to be displayed on first row, middle of your screen, on the first row. So if you want at the middle of the thing, so you have to divide it by 2. That is 1260 divided by 2, 9260 divided by 2. So this will be 630 by 480. So if it's divided by 630 by 480 as the vertex, so then the point will be displayed at the middle of the screen. So this is nothing but what? This is a pixel position. This is a pixel position on where that particular point has to be represented. So since in the GL begin, what is the parameter you have passed? So we have passed the parameter as GL point. Okay. So now, whenever you are going to have that particular GL point, so unless we specify other attribute values, so what the OpenGL will take? So OpenGL parameters are default. This is the default size and color. If you take any geometry, so if you are not specifying any attributes in that one, so then it is going to be a default values what it is going to take. So it's going to be displayed with the default size and color. So if you take the default color, so the default color of a primitive is what? White. Okay. So now if default point is size equal to the size of the single screen pixel. So single screen pixel is as I told you that. So can anyone tell that what is the size of the matrix you are going to have for this particular screen? So this is 1, 2, 3, 4. So 1, 2, 3, 4. So this is 4 matrix. So it is going to have 16 pixels here. For example, I am telling. So it is not the case that it is would be a 16 pixel. So it is going to be a different. Okay. So that is how it will be differentiated. So now, whenever you are going to have this particular functionality, so if you take one example, so if you take the one example of the program which you are going to write, so that there are 2 different versions where you can write function. Inside, you can have the word GL begin. So GL begin is the API. So this is the API what they are going to write. So what it is going to take as a parameter here, it is going to take the parameters what GL points. So when you are taking the as a GL point, what it is spelling, what it is telling. So it is going to specify that you are going to place the points onto your screen. As I told you previously, is this GL begin specify what is to specify the type of the object. So now, so each whenever you are going to have this particular begin as point, so whenever you are defining that one as vertex, so what the vertex is going to place? The vertex is going to place the points in the specified coordinate. So as I told you that, so this will be the 0, 0. So this will be the end at the bottom. So when you are going to have the screen size. So if your length is, if your number of rows is 1960, the number of rows is 960, it will be 960 divided into 1280. So this will be the number here at the bottom. So top left 0, 0, bottom right it will be 960 by 1280. That depends upon the type of the screen which you are using. So different screen will be having different resolution or different pixel. So that is how that depends upon the size of the screen which you are using in your system. So if the size of the system is huge, so then the number of pixels can also be increased. So that is nothing but is going to be specified by the resolution. So what the resolution specifies? The resolution specifies the number of pixels which you have fixed onto your screen. Okay. So that when you are fixed, that is nothing but what? That is a matrix. So it's a matrix which is there in the matrix form. So now when you are going with this particular point, so this particular begin what it's telling to the OpenGL, it's going to tell to the OpenGL that you are going to place the points with the vertex. So if we take with the GL vertex 2i, the GL vertex to 20, 100. So what it is going to do? So it is going to take the pixel of 50, 100. So assume that it is, if you take this one as row, column, for example, so it is going to take the 50th row here it will take. So here it is going to take the 100 column. So if you take the 100 column, in this particular place is going to place the point. Okay. So similarly, if you take the GL vertex of 2i 75, 150, so that is going to take the coordinate position for this particular thing x and y. So x and y is going to take. So in this particular normally it will be x and y axis. So according the along the x-axis it will be 100. So along the axis it will be 200. So in this particular point, so it will be it will be placing it will be printing the point on the screen. So this is how it is going to print. What it is going to print is going to print the points. So the symbolic constant what we are going to use for placing the points is called as what? GL points. Okay. So symbolic constants what you are going to specify. So now when you are going to have this particular case, so another way of writing this particular program. So you are passing the parameter directly into the vertex. So other part is what? So you can define the points initially as an array. So that particular values I can pass into the vertex. Okay. So vertex functionality. So specify the coordinate place for precision points in arrays. Okay. So I'm going to initialize the array as what? So that it is going to take how many values? It's going to take 2 values. So it is how many rows and how many columns. So it's going to have 2 rows and 1 column. So 2 into matrix. So this is what 2 is matrix. So it's going to have 50, 100 as the values in this one. So already you know that how to define the array and all. So how to define the array and how to initialize the array. So this is what. So both the time I'm doing the same. So that is I'm defining it and I'm going to declare it and I'm going to initialize it. Okay. So all these 3 operations are coming in a single line. So I'm going to initialize the variable as what? Integer type and point 1. So what is the values I'm passing or initializing? I'm initializing the value with 50 and 100. So at this particular coordinate system, so it is going to print what? Point. So here once you declare the 3 things, so in the GL point of vertex, so you can see it, if you want to pass the array values, so it's not going to be a direct one. So I indicates the direct value which you are passing. So if you are passing through the parameters, it is going to be IV. So if you have GL vertex of 2 IV, so then you are passing the parameters 0.1. So what the 0.1 contains? 0.1 contains 50, 100. 0.1 contains 50, 100. So here you are going to pass 3, 0.2, 0.3. So you are going to make the end of that particular program. So in the lab, we are going to see how this will work. Okay, when you are writing a program using OpenGL. So we are going to discuss in the next lab when you come to the college. So how this particular part is going to work. Okay. So now next primitive which you are going to have is GL lines. So first is your GL point. So that is it's going to print the points on the given coordinates. So next primitive type is what? Lines. So here what will happen? Successive pairs of vertices are considered as endpoints. So whenever you are going to have the vertices given 2 vertices find it, so then they are going to consider as endpoint. So because GL line what it is going to place the object, so it is going to place the line. If you want to have the line, how many vertex you require? two vertex. Line requires how many vertex? Two vertex. If you want to have two vertex, this is one vertex, for example. So this will be another vertex. So between these two vertex, I have to join the line. So this will become what? Line segment. This will become the line segment. So these two vertices are considered as what? Endpoints. And connected to form an individual line segments, as I told you that. So when you connected these two different points, that is going to form a line segment. Okay. So now, if we take the successive segments, usually are disconnected because the vertices are processed as a pairwise. Now, for example, so the line is formed only is equal number of vertex is given. So if we take this one as vertex 1, vertex 2, okay, OpenGL vertex, okay, vertex di, okay. So if I specifying 2i, and you are going to pass the parameter and GL vertex 2i along with parameter. So assume that it is 100 comma 200. So assume this one is 100 comma 200. So for example, if it takes row into column, if it takes, this will be x and y. So along x it will be x. So along y it will be 200. So here it will be 200. So here it will be 100. Similarly, what will happen? So along x-axis it will be 200 here. Along y-axis also it will be 200 here. So this is where you are going to place the points here. After placing the point, what is going to do? So you are going to join the line. So after joining the line, what it will become? It will become the line segment. So you are going to pass at least two vertices should be there. So if the third vertex you are going to specify, so then it will be displaying only the point. So that means we obtain only one line segment between the first and second coordinate positions, and another line segment between the third and fourth positions. If you are going to have four vertex points, if the specified number of endpoints is odd, what you're going to have? So the last coordinate position will be ignored. So that means if you want to draw the line, how many minimum vertex should be there? Two vertex should be there. So if you are going to have three vertex, the third vertex will be ignored. So that's how your OpenGL is going to work. So now when you're going with the example, so you can see it here. So GL begin of GL lines. So you are going to specify the symbolic constants, as I told you that. So this is the name of your symbolic constant. So where the symbolic constant will be placed inside your header file. So that will be placed inside your library or header file. So this library is the name of what? Header file, which you are going to have. So the library is nothing but as I am specifying with GL. So it will be included inside where? So it will be included your gl.h. Okay, this particular header file which you are going to have, this function will be included in gl.h. So now I'm going to initialize this particular IV of P1. So already we have defined what is P1 and your P2. So if it will make the line between P1 and P2 here. Okay, P1 and P2. This is a two vertex I'm going to have. Next, I'm going to initialize the another vertex P3, and I'm going to initialize another vertex, fourth vertex P4. So it is going to join the vertex P3 and P4 like this. So now even number of, because four vertex over. Now I also defined what. So I am also calling the function for the fifth iteration. So if you are calling the function for the fifth iteration, what it is going to have make. So as I already told that, so if you want to draw the line, how many vertex is required? Two vertex is required. Two vertex is required to draw the line. So since I'm going to have five vertex, so what it is going to have to do? So it is going to ignore. It's going to ignore the third vertex command which you have initialized. Okay, so then you are going to end it. So this particular vertex will be ignored here. So similarly, you can take another example. So if you go with the successive digital lines, so this is where all these segments which have been defined, so that will be interconnected. So successive vertex are connected by using line segments here. So if you are using the symbolic constant GL line string, even if you take this particular symbolic constant where it will be defined, so that will be defined inside your gl.h. That will be defined inside your gl.h. Since you are using the functionality from only GL. So if it is going to have GLU, then it will be stored in glu.h. So or if you are using glu to t.h header file, then automatically what it is going to have, it is going to have the library from GL also, and it is going to have the function OPFA from GLU also. Okay. So now, however, the final vertex is not connected to the initial vertex here. So you can see that this is the final vertex. This is the initial vertex P1 where you have started. So those two vertexes, it is not joined. So if you are going with GL line strip, what it is going to do? First, it is going to join P1 and P2. Next, it is going to join P3 and P4. So it is going to join the P2 and P3 also. Strip that one, and it is going to join already and P1, P2, P2 and P3. So and P3 and P4, and it is going to join P4 and P5. Okay, this is how it is going to join. Okay, it is going to join all these 3 points because it is not going to take in even way. It's not going to, because you are specifying it of what? Strip it. Okay, so these successive vertices are defined using the line segment. So now initially what will happen when you define P5, so that is going to be end. So then if I want to make this one to be loop, so I have to make use of the command loop there. So that I have to loop it. So that you are going to have another command called as GL lines loop. So when you come across the GL lines loop symbolic constant, so this symbolic constant, what it is going to perform, this symbolic constant is going to close the initial and the final vertex. So your P1 is the initial vertex which you have defined. Your P1 is the initial vertex, and your P5 is the final vertex which you have defined. So now if you specify that one as GL line loops, so that will form the loop. Okay, that will form the loop. From where it will start? From P1, P2, P3, P4, P5, P6. So it is going to form the loop. So when it is going to form the loop, when you are going to have the GL lines loop symbolic constant. Okay. So just take up one page now.